The purpose of this program is to allow a user to type in as many resistors as they want and then terminate on the condition that the last resistor entered is going to be 0. Now if we take a look at our code here, we have explain. It's a function that's going to print out this message. That's pretty straightforward. We've done that before. And if we take a look at the bottom, we have try again yes or no, and that's based on our do. Well, again, it's not equal to small n, and it's not equal to capital N, and we're changing the value of again in the scanf here before it hits that, because do while loops check their condition right at the bottom of the loop. So we already understand the do while, we understand the explain. What we have to understand is all the rest of the stuff that goes in here. Now if we take a look, we have a couple variables we're going to have to declare, sum and count. Now sum here, because we're adding resistor values, or 1 over resistor values actually, sum is going to have to be declared as a float. Now count will be set up as an integer, because we're going to say enter parallel resistor 1, where 1 is going to be whatever count has. And then it's going to say enter parallel resistor 2 the next time through, and so forth. So count will be an integer. Now what we're going to do is we're going to say printf scanf, and that's what this is going to be. There's a combination of printf scanf here. The printf here is going to say enter parallel resistor, and then it's going to put out the value of the count here, and then say 0 to stop and wait for you to type in something from the keyboard. If you type in a 1, then it's going to say sum equals sum, which was 0 plus 1 over 1, so sum will now be 1, and then it's going to increase count to 2, and then screen is going to get count in terms of a printf before the scanf. So enter resistor 2. So since count's 2, it's going to print out the 2, and then it's going to do a scanf here at the bottom of the loop. Now once it does a scanf and you type in a 1, it's going to go back here and it says is resistor not equal to 0. So 1 is not equal to 0, and it's going to continue through here over and over, printing out the resistor numbers as part of count and going through here until you type in a resistor value of 0. Now the resistor value of 0 will be typed in here, so it says it's 0 when you type this one in. It goes back up as it says is 0 not equal to 0. That's not true, so it bypasses all this and comes out. And that's the normal sequence that we're going to have as long as the resistor value that you start with is not 0. Let's take a look. If we happen to scanf a 0, it says it is 0 not equal to 0. That's not true, so it's going to bypass all of this stuff here. The only way that sum can be 0 is if you typed a 0 in as the first element here. And there's a problem with typing in 0, because in the calculation 1 over 0 is infinity, and you cannot do that. It will give you an error. So that's why if you typed in 0, it's going to come down here. It says if the sum is 0, then print the message resistor is 0, because this is a special case. And then it's going to ask, do you want to try again? But for the normal stuff, it's going to have some sum that's not 0. So for the most part, we're going to say our total is going to get 1 over sum, because the sum will be the sum of all of these additions here. Resistor total, 1 over resistor total is the sum of these values. So resistor total is going to be 1 over that, and the screen is going to get count minus 1, because count is going to be at 5 here. It's going to say parallel resistance 4, count minus 1, which is 4 resistors, is the value. So that's all of the details that you have in this structured diagram. All you have to do is turn this into code.